Topic 8-2, multiplying radicals. This can be referenced with our Holt textbook, chapter 11, section 8 on page 816. Okay, where multiplying radicals is different than adding and subtracting. We were thinking of like terms. With radicals, when there's something on the outside, nothing on the outside, it's understood to be, this is actually number 1, it's understood to be a 1. So this is multiplying a square root of 5 times the square root of 6. So you can assume there's a 1 in front of both of these. So that's just multiplying the 5 with the 6. Very different than what we did when we were adding and subtracting. So this becomes the square root of 30. This cannot be factored with perfect squares, so we leave it as square root of 30. Because 10 and 3, 10 is 2 and 5, you'd have a 2, a 5, and a 3 to get your factors out of that, and none of them are a pair, so you leave it like this. However, this one, when you multiply the square root of 24, well, the square root of 24 is 4 times 6. Well, 4 is a pair of 2's. So 2 times 2 times 6 would get you to 24. A pair of 2's is factored to the outside of the radical. Sometimes I show this with an arrow key, an arrow line. So that it shows that this sets of 2 goes to the outside and this 6 stays underneath. So 2 square roots of 6 now is your answer, because you've already done the multiplication of 8 and 3. Okay, look at number 3. I've shown this here just to show that you're multiplying your whole numbers, then you multiply your radicals. 5 times 6 is 30. 7 times 2 is 14. This actually is already simplified. 14 has no perfect squares, so you leave it. Alright, look at this one. Negative 2 times 5 is a negative 10. 6 times 8 is 48. Well, you have a pair of, because you can say a pair of 2's. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So if you want to think about and put it in your calculator, we learned in the last topic 1 how to put this in y equals and find the factors. This would actually be, how was that, 16. 16 times 3. Well, 16 is a pair of 4's. So you can think of it this way or this way, however you like to simplify this. But you do know that you're multiplying these two together, because both of those pairs factor to the outside. So you actually have 4 factoring to the outside and a 3 staying underneath. So that 4 times the negative 10 is where we got the negative 40 square roots of 3. So study that carefully. Radicals, sometimes it takes lots of examples to finally get this completely understood. Negative 6 times negative 8 is a positive 48. A square root of 2 times square root of 2 is a square root of 4, but a square root of 4 factors to a pair of 2's. Therefore, completely factored outside the radical as a 2, so that is a perfect square. It completely goes away, so that you're just doing the multiplication of 48 times 2, which is 96. Okay, be really careful about this one. If you've got the square root of anything and you square it, it is just what's underneath. You're always going to see, just like when we do Pythagorean theorem, the very last thing to take the square root of c squared, because you're looking for the hypotenuse, which is just a c. So think of that as a square root of 5 times the square root of 5, which is the square root of 25. Therefore, your radical goes completely away, because this is a perfect square. And know your perfect squares. We've done that in previous units too. Okay, let's look at number 7. Still on 8, topic 8-2 still. Alright, because this is a square on the outside of a radical, you have to think of that as 2 of them. So what you're doing is you're taking this square and making the 3 squared and also the 2 squared. Well, we just learned that if you square something that's square rooted, it's just a number. So that's where this 2 comes from, because square root of 2 times square root of 2 is square root of 4, which is just your 2. So your radical completely goes away. But don't discount 3 to the power of 2. And be real careful. A lot of students will say 3 to the power of the 2 and say that's 6. No, that is wrong. It doesn't mean 3 times 2. It means 3 times 3. So anything to a power is that base number by its times itself. So that's where 9 times 2, and this answer ends up being 18. Okay, so the next one has a fraction in it, but you can actually multiply the fractions together if you'd like, or look at it closely. This has a common factor with the cross, your multiplication with the numerator denominator, and this one does too. So you can simplify before you multiply, because if you multiply 3 and 14, you're going to get a big number. Same thing with 7 and 27. So if you can reduce this, 3 to 24 is 1/9, and 14 divided by 7 is just a 2. 2 times 7 is 14. 1 times 7 is 7. So that's how they've crossed out everything just to get it down to 2/9. Now for 2/9, if you take the square root and just separate it, it's under the whole, this fraction is under the whole radical, but if you can, this means the same thing, to show it this way. Now what we're going to do is we're going to show something about rationalizing. Well, no, this one actually didn't have to be rationalized, because the square root of 9 is 3, and so you leave that. You're just taking the square root of 9 and leaving this square root of 2. So that's where that came from. Okay, last one for this one. You've got 5. This one we're actually going to multiply because nothing's able to cross reduce. So 5 times 1 is 5, and 3 times 12 is 36. Split this up, the numerator and the denominator, into 2 of their own radicals with the division sign, the fraction between them. The square root of 36 is 6, and the radical is not simplified. You keep it under the radical. And that concludes the first part of dealing with multiplying radicals.